transformation matrices in 2D. We are going to start with the concept of the quiver command. So, in maths and science, understanding vector fields is very important for analyzing various phenomena such as fluid flow, electromagnetism, and other concepts. MATLAB being a powerful computational tool, it offers a versatile command known as quiver. So this is to visualize vector fields, or we use this command to visualize vector fields. In this short lesson, I am going to delve into the basics of the quiver command, its significance, and how to effectively utilize it to gain insights into vector fields. I know in class we have done vectors, but what is a vector field that I'm talking about? So a vector field in math is a mathematical construct that assigns a vector to every point in a given space. These vectors typically represent quantities such as velocity, force, or electric or magnetic fields, and their direction and magnitude can vary from point to point. So one might ask, why use quiver command? So the quiver command in MATLAB is specifically designed to visualize vector fields. It allows us to plot arrows at specified points where the direction and magnitude of each arrow represent the direction and strength of the corresponding vector in the field. This visualization representation aids in understanding the behavior of the vector field, and it enables us to analyze its characteristics more effectively. So let us look into the syntax and its usage. So I have a command here, quiver. Okay, quiver. So inside it you have x, y, p minus x, q minus y, s, and you have this color. Okay, so x and y here, x and y, actually it's matrices of vectors specifying the coordinates of the points where arrows will be plotted. What about this? P minus x, q minus y. These are matrices, again, matrices of vectors, but specifying the components of the vectors at each point. These can be expressions that modify the original x and y values, allowing for transformations or adjustments. What about this s? This s is a scale factor for the arrows, determining the length of the arrows in the plots. What about this parameter, color? This parameter allows you to specify the color of the arrows. It can be a single color, for example, K for black, or M for magenta, R for red. Yes. So what is the purpose of specifying colors? So specifying colors in the quiver plot can be beneficial for enhancing visualization and conveying additional information. So by assigning different colors to arrows based on a certain criteria or properties, you can highlight specific regions or features within the vector field, aiding in interpretation and analysis. Yes. So the length p minus x, we're going to call it u, is the horizontal component of the vector joining xy and pq, and the length q minus y, okay, is the vertical component. Therefore, the command quiver will draw an arrow corresponding to the vector with origin at the coordinate xy, which is this one. So in extending the two-dimensional case to 3 dimensions, the command, so we're gonna say quiver 3, okay, x, y, z, p minus q, q minus y, r minus z, s in color. So this will draw an arrow with tail at the coordinates x, y, z, and the head at p, q, r. For example, drawing the vector a with tail at the origin 0, 0, 0, and head at 1, 1, 1, as well as the vector b with tail at 1, 0, 1, and head at minus 2, 1, 2 is quoted as follows. So you're going to say A equals to quiver 3, okay, 0, 0, 0, 1 minus 0, 1 minus 0, 1 minus 0, okay, so you have your tail 0, 0, 0, head 1, 1, 1. So this way you have 1 minus 0, 1 minus 0, 1 minus 0, and 0. I'm going to say hold on, okay, B equals quiver 3. B equals quiver 3, 1, 0, 1, minus 2, minus 1, 1 minus 0, 2 minus 1, 0, and comma, dash, dash, comma, hold off, okay, hold off, legend, bracket, A, B, title, vectors in 3D, vectors in 3D, okay. So this will give you this vectors in 3 dimensions. So actually, I didn't explain why we use hold on. So we use hold on to retain the current plot, and we turn off the hold with hold off to release the current plot state. Okay, yes.